So we used our first rule, 2n squared, to help us know how many electrons could go into each of the energy levels or shells. And here's the second rule. I've written it a couple of different ways. The first way to say it is simply that the maximum number of electrons that can go in the very outermost energy level of every atom is 8. Another way to say it is that having an octet of electrons in the outer energy level makes an atom that's very stable. And that actually is why I use the number 8 over here. Because with the exception of helium, which doesn't have 8 electrons, all of the atoms that fall into group 8 are the ones that have, look, 8. That's the stable octet. We say that they're stable. Another way to say it is that they are inert. Either way, what we mean is they don't react willingly with other atoms. So what we find, in fact, is that other atoms can often gain, lose, or share electrons in order to mimic this electron configuration. And I think what I'd like to do is start with this atom over here way in the lower left corner, sodium. In order to mimic the nearest noble gas, what it's going to go for is go for number 10, element number 10, which is neon, and it has very nearly the same electron configuration. All it has to do is lose this outer shell electron. The way we write that as a chemical equation is we'll write sodium, and I'm going to write atom down here. And I will say it as a chemical equation. A sodium atom will yield a sodium ion plus an electron. Now, about that ion, sodium has 11 protons, and initially, the atom at least, had 11 electrons. But if you lose that electron, you now have one more positive charge. So the ion is going to have a +1 charge on it. Remember, atoms are electrically neutral. They have the same number of protons as they do electrons. Not so with ions. And I wrote this electron over here really as kind of a bookkeeping thing, because it's like algebra. What's on the left side of the equation has to equal what's on the right side of the equation. So even though the electron is no longer attached to the sodium, I'm putting it over here because I can't make or destroy matter. It's just a thing. Notice that all of the group 1 elements have 1 electron in their outer energy level. And guess what kind of ions they're going to form? Each one of them is going to lose that electron to look like the previous noble gas, of course with the odd exception of hydrogen. Remember, a hydrogen atom is 1 proton, and the most abundant of the hydrogen isotopes doesn't have a neutron. So it's a proton and an electron, and if you lose the electron, you have a proton. So we sometimes say that's a proton. It's not precise. It really is. It's a hydrogen atom, and in chemistry they'll call it something entirely different. We're just not going to go there. Guess what happens in group 2? Here's beryllium. It has 2 electrons in its outer shell, but it can have an electron configuration similar to helium if it loses 2 electrons. So I'll have the beryllium atom will yield a beryllium ion plus the 2 electrons that it's going to lose, and its charge will be what? +2. Does that make sense? What you could do is kind of like that. Draw a line across the periodic table, and those elements that are to the left of that line, those are the metal ions. And metal elements, and those elements, when their atoms become ions, they will lose electrons to form positive ions. And you may know positive ions by another name. They're sometimes called cations. We're not even going to talk about why. Here I have very nearly the same slide. I've left carbon over here by itself. What we're going to find is that rather than gain 4 electrons to make 8 or lose 4 electrons to bring us back to 2, what carbon is going to do is share electrons to get itself up to 8. So we're going to leave that aside for just a moment and look at some of the things, and these are things over here on this side of the periodic table that are going to gain electrons in order to reach 8. So here I've just redrawn and sort of formalized the process of oxygen, the atom, becoming oxygen, the ion. So this is the oxygen ion. And again, if I were writing this as a chemical equation, I would say that I added to the oxygen atom 2 electrons to produce the O minus 2 oxygen ion. And just to show you another one, here is chlorine, very common in biology. The chlorine atom has an atomic number of 17 protons, so 2 and 8, that's 10, 17 electrons. Do you see that? I am 1 away from having that stable octet in the outer energy level. So the chlorine atom, if I can just add 1 electron, will become the more stable chloride, we add that IDE to the end, chloride ion. Okay? So over on this side of the table, we find atoms that will gain electrons when they form ions. And over on this portion of the table, we find atoms that will lose electrons. They form positive ions. You may have heard of positive ions called cations. The negative ions are called anions. Negative ions. I'll bet you can see where I'm going with this.